Hi everyone. So in this session, I'll try to cover the Ballerina tooling. I'll try to do an introduction to all of the tooling so that you can try them out when you write Ballerina programs. Yeah. So this is like the nutshell of all the Ballerina toolings that support that we have. So as you can see, we have three editors. Composer is one of our own editors that we specially wrote for Ballerina. So the main purpose of it is to streamline integration development. And then we have two editor and IDE plugins. One is VS Code and another one is IDEA. So each of these plugins are fairly matured as of now, and they have comprehensive language support. And also there's a key component called Ballerina language server. The primary purpose of that component is to provide language support for other editor plugins and composer. And also we have a wide array of command line Ballerina commands which are useful in various stages in development. So we'll go through each one. So if we look at the core features of the tooling, we can summarize into these points. First, and the unique feature in Ballerina is the diagram view. And also we have the language support and debugging. So as of now, all the editors has the debugging support, including the plugins. And we already covered the testing framework in the previous talk. And we also have package management, documentation support, and special support for Swagger and Open API integrations. So let's look at the diagram view. So the primary purpose of the diagram, as we found out, is when you write a Ballerina program, it kinds of validates the program that you write. It can use to validate the program. And also at a later stage, when you're reading Ballerina programs, it serve as a documentation into what the program does. So over time, we ourselves are kind of now rely on the diagram in order to understand Ballerina code. Yeah. So and so the diagram is actually still evolving. As Sanjeev said, language is also still evolving. There might be changes. So so those changes will also affect the diagram, and we'll continue to improve on the diagram. So to give an idea, so this is how the diagram was 1 year back. So as you can see, we have progressed quite a lot during the past year with the diagram. Yeah. So the next major feature is the Ballerina language server. Ballerina language server is simply implementation of language server protocol for Ballerina. So basically, language server protocol tries to solve M2N problem with IDE development. So basically, before language server protocol, if you try to write plugins for a particular language for different IDEs, you have to go to each plugin and implement the language server, the language support into those plugins. So language server protocol try to minimize the duplication of the implementation. Yeah, and currently Compose and VS Code plugin use Ballerina language server to provide the language server support. So as of now, language server is fairly matured, so it has like a lot of capabilities of the language server protocol. I'm sorry, I have a cough, so sorry about that. So, so these are like the overall high-level language server features. So you have diagnostic, suggestions and auto-completion, finding references, go-to definition, hover support, signature help. So let me do a quick demonstration of the features. So here, when I start to type service, you can see you get a suggestion. So here the suggestion is actually a code snippet. So if you select that, it will inject a full block of code. Then you can use tab to jump on the placeholders and edit the specific names. And as you can see, you get this wavy line. So that's the diagnostic feature kicking in. So these particular messages are the actual compile errors that you would get when you run the program. And in this case, if you hover here, you can see a bulb. So that brings out the code action feature of the language server. So in this case, I can select import package, and that will correct the semantic error we had in the program. And like, so other completion features include like completing functions, action invocations. One of my favorite completions is the match expression completion. So let's try that out. So I'll define a union type here. So if we try to write a match statement for this variable, language server will automatically suggest that. So once you select it, it will automatically fill out the match statement, which like kind of saves you a lot of typing when you're writing code. And other features include the hover support. So once you hover the function, you can see the description documentation of that function. So these documentation we extract from the documentation block in the Ballerina code. And we also have code navigation support as well. So once you click, it will jump to the particular function. And also you can see a preview of the implemented function with the lens. So these particular features, of course, work across files. So if you want to know about like the language server support, I would suggest to read the user guide for language server. So basically, there are like lot of minor features developed around the language server capabilities. For example, there are like lot of code actions, and we'll be continue to improve on those. So it's always good to have a look at this user guide. So the next tool set is related to package management. So you already see these tools work in Paul's presentation. So So we have the Ballerina Central, where all the act as the central package repository. And using Ballerina push, you can push a package to the repository. And also using pull, you can download a particular package into your home repository. One of the things that need to mention is like package management is already integrated with the compiler. So you do not have to necessarily pull a package to use it. You can simply add the import in the Ballerina program, and once you compile, it will automatically download the package and build the Ballerina program. But for the time being, you have to use Ballerina pull in order to get support in the language server. So language server suggestions would work once you pull a package beforehand. So this is what the central looks like. And the next tool that is quite useful is the doc generator. Basically, you can use it to generate API docs. If you can see the code block, you see the documentation block of the submit function. Here you can see we support different markdown highlighting markdown features, and also we have like special set of tags in order to tag the attributes of the function, parameters of the function inside the documentation. Next, one of the interesting features that we have is Swagger and OpenAPI support. So basically, the Swagger command that we have can be used to generate a service stub. So basically, if you use mock, it will generate the service stub, and you can start implementing the service from there. And then you can use Swagger client if you want to generate a connector from a Swagger file or an OpenAPI document. And also, the Swagger tool can be used to export the Swagger definition out from a already implemented service. So I'll do a quick Composer demo now. So this is how the Composer looks like. So you can see all the Ballerina by examples in the welcome page. So let's start with a simple scenario where you have to implement an API. So I'll create a new file. And here, one of the special features Composer has is the graphical editing. You can go to the edit mode and add a HTTP service. As you can see, when you edit graphically, the code will automatically generate on the other side. And then once you create a service, the next thing would be to describe the service definition. In order to do that, Composer comes with a Swagger view. You can activate it like this. And here you can edit the Swagger definition of that API. So let me create another resource. So once you are done with the API definition, you can go back. So then it will automatically update the code with all the new resources that you define. So once you have the API defined, API design implemented, the next thing would be to implement each of the resource. So to do that also, you can either write code or you can use the graphical editing capability. So here you can add workers, and also you can add endpoints. And once you have endpoint, you can define your control flow and also add actions. So this feature will let you kind of create the outline of the program, and then you can dive into the code editor in order to implement it. So next, I'll demonstrate the debugging capabilities of the program. So here I'll open our demo sample. So here you can run directly from the composer. So once the service is up, you would get a try it option, and it will load a try it client. So here you can select the particular resource you want to invoke. Yeah, so here it sends an error. I'll resend it again.
It's a Twitter error because it's a duplicate message.
Yeah. So the second call succeeded. One of the interesting features that we have in this try client is the trace logs. So basically, let me clear this and re-invoke it. So here you can see the actual request the request coming in to the service and the request going out from the Twitter connector. So this will help you to quickly debug certain errors. So if you click on each line, you can see the payload of the message as well. And here, if you look at these arrows closely, you can see it resembles the arrow direction that you see in the diagram. So basically, this signifies the inbound and outbound request of the messages. So let me quickly demonstrate the debugging capabilities. So here I'll go to the console, stop the service and start it in debug mode. And here I'll put a debug point. Yeah, so this supposed to be this particular debug line. Let me try that again. Yeah, so I'm sorry, it's not catching up the debug point. So basically, this feature is available in other plugins as well. So it should work as like in the other programming languages. It will hit at the debug point, and you can navigate through code. So in terms of like future development of the tooling, so mainly we are focusing on improving the language server support and to add in more features around that. And also we are trying to bring in like the features of the composer into other editors as well. For example, we'll be adding the graphical editing support soon in the IntelliJ IDEA plugin. So the aim is to try to create a similar experience across all the IDEs. And I hope like you will try these tools out and send us your suggestions and feedback. And also, if you find any issues, please report them in our GitHub issue tracker. So that's about it from tooling.
Questions for Joseph? There was one online.
Okay.
Is the composer going to turn into an observability tool for developers?
Not really. Like so, the idea of tracing is to provide you some additional capabilities in order to debug the software that you write. So we might bring in some support to like viewing, for example, metrics, messages and stuff. That is purely to help you in when you write the program, when you add in matrices, you might want to see like what are the messages that you get. So in order to support that, we would add in features, but it won't be a...
It won't be some sort of dynamic view presentation?
No.
No.